All right, so for number 1, we're looking for critical values. Critical values are where the first derivative either equals 0 or is undefined. And so we're going to look at the f prime row, and we're going to look for anywhere where f prime is 0 or undefined. That would be here, and here, and here. Now, these parts right here are not undefined. We don't know what they are yet, but we're going to figure them out later. But they're not undefined. They actually have values here. We just don't know them yet. But these are the 3 places where the first derivative is 0. Critical values are the x values where this happens. And so the critical values will be -5, 0, and 2. And there's our answer for the number 1. All right, for number 2, what are the relative minima? Relative minima happen anytime f prime equals 0. Well, actually, let's just say relative minima happen when you have a critical value. So we could have a relative minimum here, here, or here. But there's a little bit more to it. We have 2 choices for finding relative minima. Method 1 is you look for the place where the slope changes from negative to positive. In other words, f prime goes from being a negative number to being a positive number. That's one way you can tell. Another way you can tell is because of the fact that this is concave up, f double prime will be positive at that critical value. The critical value is the tip of these shapes. So that's 2 ways you can tell. So let's go ahead and take a look at this first one here, this first critical value. I can't use method 1 because I don't know what the slopes are to the left and the right. I can't tell if we're going from a negative slope to a positive slope because they're not there yet. So we'll ignore that. So let's take a look at method 2. F double prime is positive. So that's a yes. So right there we have a relative min. Let's go ahead and take a look at another critical value. This one here. This one has a negative second derivative. So that's not a relative minimum. How about this one? Well, here I don't know what the second derivative is. So I can't use method 2 this time. I have to use method 1. The slope to the left is negative and the slope to the right is positive. And so that is another relative minimum. Now we have to remember, though, that the relative minima are the y values. So keeping that in mind, here's how we would write our final answer. We would say there is a relative min at the point -5, -5. That's this one right here. And the reason for that is because f double prime is positive. That's one way you can tell that you have a relative minimum. For the other one, this one over here, we could say there is a relative minimum at 2, -1. because f prime changes from negative to positive at that point. Okay? You would do the same thing for the next question, number 3. But for number 3, it's opposite, because now we're looking for a relative max. So to find a relative max, once again, you're going to look at your critical values. And there's 2 ways you could tell, once again. There's method 1, and there's method 2. Method 1, the first derivative goes from positive to negative. So on the left side, we would have a positive slope, and on the right side, we would have a negative slope. With method 2, instead of looking at the first derivative, we would look at the second derivative, which tells us that it would be concave down, so this would be a negative second derivative. Okay. Now we already know that this critical value and this critical value give us relative minimums, so we don't need to look at that. So the question is this last value here a relative maximum? And as you can see, the second derivative is negative, so the answer is yes, that is a relative max. And so what we would say to that then is we would say for number 3, and then 0, 2, since f double prime is negative at that point. And, well, I guess we could also say, and f prime equals 0. So since f prime is 0 and f double prime is negative, then that's what makes it a relative max. And I should have put that on the last one also. You have to state that either f prime equals 0 or f prime is undefined. I forgot to do that. All right. Let's go ahead and move on to number 4, points of inflection. Points of inflection are where f double prime changes signs. And what that means is that the graph of f would be changing from concave up to concave down, or vice versa. So for instance, right here, it's going from positive to negative. And so the point negative 2, 0 is a point of inflection. Here's another one. Here we're going from negative second derivative to a positive second derivative, and that happens at this point here. So for this particular problem, then we would answer there's a point of inflection at negative 2, 0 and 1, 0, since f double prime changes signs at those points. All right. Number 5. Complete the f prime row. They want to know, what are these? Are they p or n? Well, we already know that at this point, because the second derivative is positive and this equals 0, we have a concave up function at this point with a relative minimum here. We saw that back at number 2, right? So if this is what my graph looks like at this point, then the left slope should be negative. That's a negative slope moving downwards, and this slope is a positive slope. So we would say that on the left side here, it's a negative slope, and on the right side we have a positive slope. Go ahead and take a look at number 6. Complete the f double prime row, assuming the second derivative test is conclusive at x equals 2. All right. So if the second derivative test is conclusive, that means that f double prime cannot equal 0. Now, if that doesn't ring a bell for you, then you might want to go back and look at, I think it's lesson 5.5, if I'm not mistaken. Whichever lesson it was where we talked about the second derivative test. If the second derivative ever equals 0, that means that it's not conclusive. But since this one is conclusive, we know that this can't equal 0. So that means it either has to be positive or negative. It can't equal 0, since the second derivative is conclusive at that point. X equals 2. All right, so now the question, what is it? Well, as we saw back on number 2 also, we saw that since this one had a negative slope on the left and a positive slope on the right, this was a relative minimum. Well, if you have a negative slope on the left and a positive slope on the right, then this is concave up, which means that the second derivative would have to be positive. So we would put a P right there. What are the absolute extrema? Remember the candidates test. So for the candidates test, we put our endpoints in, -7, +4. And we also put our critical values in there, which we know are here, here, and here, because that's where our derivative was 0. We found that back in number 1. We found our critical values were -5, 0, and 1. And then we just have to find the y values for these points. So the y value for -7 is 6. The y value for -5 is -5. The y value for 0 is 2. The y value for 1 is 0. The y value for 4 is 1. And the biggest number is our relative max. Not our relative max, I'm sorry, it's our absolute max. And our lowest number is our absolute min. And that's it for number 7. Let's go ahead and take a look at number 8. For number 8, they want us to sketch a graph of the information. So for number 8, I would say we're going to start by plotting our points first. So let's plot our points. -7, 6. -5, -5. -2, 0. 0, 2. 1, 0. 2, -1. 4, 1. All right. All right, now we're going to go ahead and make sure our slopes are correct. So we have at 7, at x equals 7, we have a negative slope, so it should be going in a downward direction. Between 7 and -5, we said this was negative, so it's going down also until we get here. At -5, -5, we have a 0 slope, so it's going to be a little bit flat there, we'll say. And then at -2, 0, we have a positive, oh, this was positive also. Between -5 and -2, it was positive, and at that point it's positive. And then in between -2 and 0, we're still positive. And at 0, 2, we have a flat slope. Between 0 and 1, we have a negative slope. At 1, 0, we have another negative slope, so still going down. Between 1 and 2, we have a negative slope. At 2, 1, we have a 0 slope. And at between 2 and 4, we have positive and then positive. And that's, I mean, pretty much, you're pretty much done at that point. From here to here, my graph is concave up. So from -7 all the way up to -2, my graph is concave up. So concave up from here to here, it's concave up. From here to here, my graph should be concave down. So from -2 to +1, concave down. And then from, this was positive, so from 1 to 4, it's concave up again. So that's my graph. We're just, after you plot the points, you really just kind of check to make sure all your slopes and concavity match the table, but after you plot your points, it's kind of straightforward. So that is 5.7 part B. Okay, I'll move on to 5.8. Okay, so for 2a, f of x equals 0. That means that y equals 0, and that's where this graph will be touching the x-axis. So that's here and here. F of x is greater than 0 means that your graph will be above the x-axis. All of this is above the x-axis. So that would be from -infinity to -2 is the first piece. And then from -2 up to 1 is the next piece. And then from 2 to infinity is the next piece. This, f of x is less than 0, that means my graph will be below the x-axis. And that happens right here. And so f of x is less than 0 on the interval from 1 to 2. Okay, as for the next set, all of these questions are about f prime, which is the slope of our graph. So I'm going to skip part D. Well, I guess I'll start there. F prime of x equals 0. That happens anytime you have the top of a curve, like right here, you have a flat slope. So that would be a place where f prime equals 0. So we would say that that x value, which maybe is like 0.25, just estimating, we don't know for sure what that is, we just guess, is a place where f prime of x equals 0. F prime of x also equals 0 here because it's a flat line. And so that might be from like 2.5 off into infinity. All right, as for the next one, f prime of x is greater than 0. That means that the graph of f is increasing. F is going up. So anywhere on our graph where f is moving in an upward direction would be a place where f prime is greater than 0. So here, my graph is moving in an upward direction. Here, my graph is moving in an upward direction. And here, my graph is moving in an upward direction. So that would be -infinity up to -2. negative 1 up to about 0.25. And maybe like 1.5 to 2.5. F prime is less than 0. The slope is less than 0 anytime f is decreasing. So that would be happening here and here. So that would be from negative 2 to negative 1. And from about 0.25 to about 1.5. The slope is undefined in a few different places. Anytime f is not continuous, that's a discontinuity. And as you can see here, there's a vertical asymptote here, which means that the function is not continuous there. So that's a place where the derivative would be undefined. The derivative is also undefined anytime you have a cusp. So right here we have a cusp. So another place where the derivative is undefined would be at 1.5. All right, lastly, f prime is constant anytime the slope is not changing. The slope stays the same. Now what that looks like is that looks like a straight line. So anytime you have a straight line without curves on it, then that would be considered a constant slope. So I see a constant slope right here, and I also see a constant slope right here. So we would say from 1.5 to 2.5, and we can also say from 2.5 to infinity. Now right here might be a constant slope, but that looks like it's part of this parabola, so I'm going to say no, that's not a straight line, but this definitely looks like a straight line here, and this looks like a straight line, and that will make you have a constant slope. All right, the last few questions on this problem have to do with the second derivative, and that's about the concavity. So first of all, we want to look for where f prime is greater than 0, and that's where f is concave up. So this looks concave up to me, this looks concave up to me, and so I would say that we have a concave up graph from negative infinity to negative 2, and we also have a concave up graph from negative 2 up to about maybe negative 0.5. This next question here, where f double prime is less than 0, that means concave down. So this graph looks concave down to me here. So that looks like a concave down graph to me. And so I would say that we have a concave down graph from negative 0.5 up to 1.5. Now I skipped I, so I'll go back to that. I equals 0, or f double prime equals 0, where the pink and the green regions meet. So right here, for instance, that's where it's neither positive nor negative, so it must be 0. So I would say at x equals negative 0.5, or negative 0.5 there, we would have a place where the second derivative equals 0. The second derivative also equals 0 anytime f prime is constant. Okay, if f prime is constant, that means that it equals a number, and it's never changing. And so when you take the second derivative, you'll get a 0 there, because the derivative of a constant is 0. So f double prime equals 0 here because the concavity changes, but it also equals 0 anytime f prime is constant, which we saw earlier was here and here. So that would be at 1.5 to 2.5, and also from 2.5 to infinity. All right, that's for the last question on this one. F double prime is undefined anytime f prime is undefined. So there's our answer there. Wherever f prime was undefined, that's going to be our answer. So we had undefined here, and we also had undefined here. And so that was -2 and 1.5. If your first derivative doesn't exist, then your second derivative can't exist because your second derivative depends on your first derivative. All right, so there's number 2. Let's take a look at number 3. So here we're just going to turn this picture here into a graph. So we're going to start by graphing these points. That's a point 1, 0, which is probably like right about here. This is another point 3, 0. Right about there. They tell me the slope at 0 is 0, and the slope at 2 is 0, and the slope at 4 is 0. Okay? Now I don't know where my point is over here, but I know that the slope is supposed to be 0. I also know that my slope is supposed to be 0 at 2, so somewhere here we're going to have a flat line for a tangent line, and f prime of 4 equals, there's somewhere over here we're going to have a flat line too, we just don't know where. So I'm going to wait on doing this one. Let's go ahead and do this one. Now for this one, we have concave up from -1 up to 1. So let's draw that. Concave up from -1 to 1. And I also remember that I need a 0 slope at 0, so we need a flat tangent line here. It's also concave up from 3 to 0. So from here, 3 to infinity. So I know it has to start here, so it's going to go like this. And I also remember that we need a 0 slope at 4. So another flat horizontal tangent line. I see here the second derivative is negative, so that means we're concave down between 1 and 3. And I also need to have a 0 slope at 2. So concave down with a 0 slope at 2. And that's what your graph would look like. All right, let's take a look at number 5. All right, first of all, they tell us that f of 0 is undefined. So my graph cannot touch this line. When x equals 0, the function's undefined, so I can't touch that line. I see here that f double prime is greater than 0. That means my function will be concave up from -infinity up to 0. Concave up. I see that my graph is also going to be concave down from 0 to infinity. And then finally, I see that my first derivative is greater than 0. That means my graph has to be sloping up. And that's everywhere except for 0 because it doesn't exist there. So my graph would be looking something like this, sloping up and sloping up. And it can't touch this middle line, so it just kind of keeps going in an upward direction there and a downward direction there. So that's a graph that's concave up on the left of 0, concave down on the right. It's always increasing. It's increasing on this side. And it's also increasing on this side, which means that my first derivative is always 0. Greater than 0. And there you go. So that would be your final answer for number 5.